All right, happy Friday. So last time that we met, we were talking about perfect squares and square roots, and then we approximated square roots. So the next logical place to move is into perfect cubes and cube roots. So it's very, very similar to when we take perfect squares and square roots, so it's just a little bit of an addition here. Up here we have two images for you. The first one obviously is a square, and the second one is obviously a cube. So a square being that all sides are equal, a cube meaning all dimensions, length, width, and height are all equal. So let's imagine that we say this is 5. So length and width is 5, and then same thing over here, except now my height is also going to be 5. Okay, we'll kind of just use that as an example to look at. But over here, if we were using a square, we would definitely be finding area. So if I wanted to find area, I would do 5 times 5, which we now know is a shorter, easier way of saying area equals 5 squared. Okay, and that's where the idea of a perfect square comes from. And then our area would be 25, and let's call these inches, I guess. And so our area would be 25 inches squared. Okay, so now if we're looking over here at a cube, now we don't want to find necessarily area, we would find volume of this because it would be length times width times height. Okay, so the volume would be 5 times 5 times 5. Since I'm multiplying that 5 3 times by itself, I can write that as 5 to the third power, or 5 cubed is another way that we'll say that today. And that equals, I know 5 times 5 is 25. 25 times 5 is 125. And this time, let's again call these inches. So this would be 125 inches cubed this time. Okay, so it's a really similar idea. If we think back to what we said the definition for a perfect square was, we said it was the product of a number multiplied by itself twice. So this is going to be a very similar definition, except instead of only twice, now we have a cube. There are 3 dimensions, so it's the product of a number multiplied by itself 3 times. So we'll write that down. Okay, so it's the product of a number multiplied by itself 3 times. Again, we always think of that cube has 3 dimensions, so we have to multiply 3 times. And just like when we talked about square roots and squares, cubes and cube roots are inverse operations, meaning that they undo each other essentially. So if I cube something, make it way bigger, and I want to undo the cube, I would take the cube root. Okay, so those that's the main definition that we have here. So make sure you take time. We can pause it if you need to write that definition down. Okay. So I'm not going to give much time in here because I know you can press pause. Okay. So continuing, so we're going to take a little pause from the blue sheet, and now we do have our perfect cubes chart that will get passed out. So in this perfect cubes chart, just like you guys have for a perfect squares chart, except you're lucky this time you only have to know 5 of the first 5 perfect cubes. Reason being, you'll see as we start going that the numbers get pretty big pretty quickly, because instead of just multiplying a number twice, we're multiplying it 3 times. Okay, so I'm going to write this all down here. I bet you could probably do it yourself too, but if you need a reference, I'll continue to write these up here. You're going to write these on your sheet, and then when you're done, you're going to tape them into your composition notebook on a new page. Okay, this is the 5 that you are expected to memorize and know. Okay, so if we look here, we have a 1 by 1 by 1, length, width, height are all 1. So we would say 1 cubed equals 1, and the cube root of 1 equals 1. So just like we did before with square roots, make sure you're really emphasizing the language piece. Okay, so next up, we've got a 2 by 2 by 2 cube. So again, we're going to say this is 2 cubed equals, and we know 2 times 2 times 2 is 8. Okay, and again, this symbol right here, this is our radical symbol with the 3 is our cube root symbol. Okay, so in order to show that I'm taking a cube root and not a square root, I have to write that little 3 in the pocket right there. Okay, so now I'm going to say the cube root of 8 is going to bring me back to 2. Okay, I'm going to keep going. See if you can try it. So over here, I've got a 3 by 3 by 3. So I know 3 cubed, 3 times 3 is 9, and then 9 times 3 is 27. And then, so then the cube root of 27 equals 3. Okay, next one up, we've got 4 by 4 by 4, or 4 cubed. And I know 4 times 4 is 16, and 16 times 4 is 64. Right, and then the cube root of 64 equals 4. Oops. And then finally, 5 by 5 by 5. We already did that actually in our example on the first page, but we want to still have it written down. We have 5 cubed equals 125, and the cube root of 125 equals 5. So these numbers right here, 1, 8, 27, 64, and 125 are your perfect cubes. Okay, those are the ones that you're going to want to memorize. You'll find out if you tried more, they get really big really quick. Okay, I'm going to stop this video here because it'll cut me off at 10 minutes, and then we'll continue with the rest of the notes in just a second.